Now we are going to demonstrate how to carry out source emission monitoring or stack emission monitoring. This we will cover in two parts. One, how instrument is assembled. Two, what are the different steps in stack emission monitoring. Instrument contains 5 major components. 1. Main instrument or panel. This is model VSS1. 2. Probe set. 3. Inclined cum vertical manometer. 4. Pump. 5. Dry gas meter DGM. Now we will demonstrate what are the accessories inside the probe set. The probe box contains thermocouple 1 number. Its length is 0.6 meter. S-type pitot tube. Pitot extension 1 number. PU pipes for pitot 2 numbers, red and yellow colors, in 2 different colors. Length is 3 meters each. A set of 3 probe pipes. 2 probe pipes are of 0.6 meter length and 1 probe pipe is of 1 feet length. One of the probe pipe is supplied with a handle which is used to align the probe while doing monitoring. Hose pipes, one of nylon, other steel braided. Both are of 3 meters length. Thimble holder 1 number. Set of 3 nozzles. Nozzle sizes are 1 by 8 inch, 1 by 4 inch and 3 by 8 inch. Ice tray 1 number. Tripod stand 1 number. This is for fixing the instrument at the place of monitoring. 2 mid-gate impingers of 120 ml capacity for gaseous sampling. 1 impinger for placing silica gel. This is also of 120 ml capacity. 1 impinger for moisture condensation of 250 ml capacity. Silicone pipes 6 numbers. Required connectors, clamps and a toolbox. Now we will demonstrate what are the functions of different components placed in VSS1 stack monitoring kit. The main panel consists of one rotameter for flow rate adjustment of PM. Capacity is from 0 to 30 LPM. Another rotameter for adjustment of gaseous flow rate. Capacity is 0 to 3 LPM. One temperature indicator. Connecting terminals for thermocouple. Switch to indicate ambient temperature in TA position and to indicate stack temperature in TS position. This red color button is used to read the temperature either of ambient or of stack. In two different positions it measures the temperature. One stopwatch. Switches for start, stop and reset the stopwatch. So there are three buttons, two black color and one red color. One is for start stop, other one is for reset, and red color is for setting the zero. Pressure meter and positive and negative connectors. Positive, negative for connecting pitot tube. Pressure gauges, two numbers for recording pressure drop in PM and gas sampling train while monitoring. On the back side of the panel are four nozzles for attaching impingers with the help of Teflon tubes shown to you earlier. There is a water level for setting the water level of the instrument so that instrument is vertically in position. There are two ports, one is inlet port for the gas and other is the outward port which is connected to the pump. So in some cases we supply a velocity monitor separately. In that case, inclined cum vertical manometer. This is in place of the pressure meter which was shown in VSS 1. So one can use either the pressure meter or vertical cum inclined manometer can be used. Again, the positive and negative terminals are there for connecting the pitot tube, and leveler is also provided for setting the level of the instrument. First of all, we would like to demonstrate how to fix the main instrument panel on the tripod stand. So we will unlock the different locks and fix to the required height. So carefully we have to fix the panel with the tripod stand like this, and there is a handle to put it in different positions. So it is set to the required height, required angle, required position like this. Yes. Once the instrument is fixed, now we will proceed to demonstrate how to make different measurements. First step is taking the stack temperature. How to take the stack temperature? For this we will use the thermocouple. Now we are going to connect thermocouple to the panel. So thermocouple contains a plug which has two colored wires. One is blue and other one is white. And please take care that both are in their right position. Next, we will insert the thermocouple in the chimney and allow for certain time to stabilize the temperature, and then we'll press the red button in stack position and note down temperature readings after pressing the read button, this blue read button. Next is how to measure velocity pressure head, that is delta P. For measuring delta P, we use S-type pitot tube. So this is S-type pitot tube. Pitot tube is supplied with an extension. So this is the extension pipe. When stack diameter is more, one can connect this extension to the pitot tube like this. So now we will demonstrate how to assemble the pitot tube for taking delta P measurements. So insert two PU pipes to the two ends of the pitot tube. PU pipes are, one is yellow color, other one is red color. Now the red color is inserted in the positive end of the pitot tube. So we have to take care that the positive end of the pitot tube should be connected at the positive of the panel. So there are also positive and negative terminals at the panel. So we have inserted the red one in the positive and yellow one in the negative terminal. So now we will insert the pitot tube inside the chimney and position the pitot tube in such a way that positive end of the pitot tube faces the flow. So if there is a stack gas flow is from bottom to up, then positive will be facing the bottom. And then take the readings of the pressure from the pressure meter. This gives the readings of delta P in millimeter of water column. Next step is how to measure static pressure of the chimney. For this, we will disconnect the negative end of the pitot and we will position the pitot in such a way that pitot is at 90 degree of the stack, and record the reading from the pressure meter. This will be the static pressure in millimeter of water column. In case a inclined cum vertical manometer is used in place of the pressure meter, then first of all adjust the level of the instrument with the help of the leveler. Next step is fill the red oil through filling plug with the help of a syringe till oil level touches 0 of the manometer. Balance steps for measurement of delta P and static pressure are same as in case of pressure meter. Now we will demonstrate how to assemble the sampling train. Sampling train for particulate monitoring, and in this case we can do gaseous sampling simultaneously, that is along with the particulate matter. For this, what we do, first of all, we will connect a nozzle, suitable nozzle, to the thimble holder. So there are three different sizes of nozzles. So depending upon the velocity in the stack, gas velocity in the stack, we will select the nozzle and we will fix the nozzle like this. Next step is we will fix the thimble in the thimble holder. So this is the thimble, and now we are going to show how to fix the thimble inside the thimble holder. There are two types of thimbles. Mostly one is the cellulose thimble, other one is glass fiber thimble. So depending upon the temperature of the chimney, we will select the thimble and fix it like this. And we will make it completely tight. It is completely fastened so that there is no chance of leakage. Now next step will be, we will connect to the thimble holder the required length of probe pipe. Here we have a small pipe, but in case the stack diameter is large, one has to select a large probe pipe depending upon the diameter of the stack. So we will fix the probe pipe like this. We have to take care that the direction of the nozzle and the direction of the handle are same as shown here, so that when you will insert the probe inside the chimney, you will not be able to see the direction of the nozzle, but you can judge it from the direction of the handle. So this handle is provided to judge the position of the nozzle when we are doing monitoring and nozzle is inside the chimney. Now we are demonstrating how to connect the hose pipe to the probe pipe. So steel braided probe pipe is connected. So we will connect the other end of the hose pipe to the inlet of the panel like this. And we have to make sure that there is no leakage. So tighten all the nuts properly with the help of spanners. For this, required spanners are already provided in the toolbox. Now we are going to connect the outlet of the panel to a nylon hose pipe, and the other end of the nylon hose pipe will be connected to the pump. So we see that entire train is complete, starting from the nozzle, thimble, then hose pipe to the panel, and outlet from the panel to the pump. So we have connected the sampling train. Now we are going to connect the ice tray. Different impingers are put in the ice tray. And it is important that before start of the sampling, required quantity of ice or cold water is placed in the ice tray. Now we will show how to connect the impingers to the panel and how to place the impingers in the ice tray. So now we are going to demonstrate how to prepare the impingers and assemble in the ice tray. The impinger shown is of 250 ml. 100 ml or 150 ml of cold water is taken in the impinger. This is used for condensing the vapors which are present in the stack gas. So this we will take to ice tray later on. There is another impinger of 120 ml. This is containing silica gel. So after the condenser impinger, we can connect this impinger having silica gel. So whatever moisture is left out, moisture remains in the gas is being absorbed by the silica gel. This silica gel is pre-weighed, and after sampling again its final weight is taken, and with the difference we will get the moisture content. These two impingers are for SO2. So for SO2 we have to take isopropanol in one of the impingers, and the other impingers will have 3% hydrogen peroxide solution. And now we are going to demonstrate how these impingers will be arranged in the ice tray, and then how these are connected to the instrument panel. This we are going to show. Now we are going to demonstrate how to assemble the impingers in the ice tray. So this is the way how we fix the ice tray behind the panel. And in the ice tray we will put enough ice or ice cold water, and then we will place impingers at their right places. There are slots of different sizes shooting to different sizes of impingers. So we will place all 4 impingers like this. Now we will make connections with the panel. We are going to connect impingers to the panel with the help of silicone pipes. And we have to be careful that the incoming gas goes to the impinger, and impinger outlet of the first impinger goes to the inlet of the second impinger, and outlet of second impinger goes to the inlet of third impinger, and so on. If we will not be careful, we can lose our sampling. Our solutions can be mixed from one impinger to the other impinger, or it may be sucked back by the panel. So while making these connections, one has to be very careful. For this, one has to take help of the instruction manual, operation manual. So like this we have connected all the impingers to the panel. And now last step will be connecting this panel now we will start the sampling. So for starting the sampling, we will put on the pump, and based on the velocity and the isokinetic flow rate calculated, we will set the flow rate in the rotameter, which is from 0 to 30 lpm, and for gases we will set the flow rate for gases 1 to 2 lpm. Now we have connected the entire sampling train, and now we are going to start the sampling. For sampling, first of all we will start the pump, check the power supply and start the pump, and then set the flow rate for the gases. First we will set the flow rate for the gases. It is set in the range from 1 to 2 lpm, and next we will set the flow rate for PM. PM, for example, if our velocity is in such a range that isokinetic flow rate calculator is 22 lpm, we can set from 0 to 30 lpm in this rotameter. So we will set the desired flow rate in this rotameter. We will continue the sampling for half an hour to 1 hour, depending upon the dust content in the chimney. After completion of the sample, first we have to close the rotameter for the gases, and then we have to close the rotameter for the PM. This is to take care that our solutions kept in the impingers are not sucked back into the panel. Then we will put off the pump, and then subsequently we will remove the thimble carefully. We will not put the upside down thimble, we will keep the thimble in upright position, and after temperature is down, thimble holder is becoming cool, then we will remove the thimble, keep it in a container carefully, and take it to the laboratory for further analysis.